Wait. It hasn't started yet. Oh yeah, recording start already. Oh wait. So I'm gonna start. We also wait. Good morning to the lecturer and my fellow friends. My name is Sam Tejas. My nature card number is 15 DTK21F2011.
Good morning. My name is Krishna Vipha and my matrix number is 15DTK21F2001.
Good morning. My name is Adrian. My matrix number is 15DT21F1018.
And so right now we are going to do a role play exercise of the flowchart, and we're going to elaborate about this flowchart topic. And Adrian is taking the role of Tejas, Vipha is taking the role of Jyoti, and me, Sam, is going to take the role of Moss. So we'll start now.
We visited a computer exhibition for school students. We saw a supercomputer, demonstration of many uses of computer and many more interesting applications.
In one of the booths, we could enter any number as input and the computer was displaying the multiplication table of the number shown above. This picture used by the person at the booth to explain the sequence of steps followed by the computer to display the multiplication table. We observed that those who did not know about computer and programming could also understand what was explained by the picture.
This picture is a graphical representation called a flowchart. One of the main uses of a flowchart is to write the sequence of steps and logic of solving a problem. Before writing the full computer program, it also helps in communicating the steps of the solution to others. So, what is a flowchart? A flowchart is a graphical representation of the problem-solving process, and it gives a step-by-step procedure for solutions of a problem.
What is a flowchart? The intro of a flowchart is various geometrical shaped boxes represent the steps of the solution. The boxes are connected by directional arrows to show the flow of the solution problem solving. The main use of a flowchart is to show the sequence of steps and the flow of a computer program. Some of the other uses of a flowchart are to communicate a solution to a problem, explain a concept, and show the logic classification of data, rules, and the flow of playing a game.
I see that various geometrical shapes are used in this application. We are eager to learn about flowcharts.
Let us start with a simple example. Look at the following flowchart adding two numbers A and B. Let us discuss the problem solution and the geometrical shapes used. So in this flowchart, here's the start, the inputs, the process, the output, and the end. Read A is 845, read B is 247. In the process, this rectangle, sum equals to A plus B, so it's 845 plus 247. And then the print sum equals to 1092. So what do you do when you are given a problem?
First, we identify the goal. Here it is addition of two given numbers.
How do you achieve this goal?
First, we identify the data that is given. In this problem, we have two numbers A and B, reading their values represented by parallelograms.
Right. What would you call this in computer terms?
Input.
The data or information that is available, which is called input, is represented using a parallelogram in the flowchart. What is the next step?
The next step is to add the numbers, which is called processing in computers.
Correct. The details of processing of data is represented in the rectangle.
The next step is to write the result of the addition, which is output in computer terms. This is also specified in a parallelogram.
Right. A parallelogram is used to specify both input and output in the flowchart. What else do you notice in the flowchart?
An arrow points from one step to the next step in the flowchart.
In the flowchart, arrows are used not only to connect the steps in the sequence, but also to show a clear flow of the problem-solving process.
Start and also end of the flowchart are shown with an ellipse.
A flowchart should give a clear indication as to where the problem-solving flow starts and where it ends. The start of a problem-solving process and the end are indicated using the ellipse.
This is just like using stepwise thinking lessons step by step to solve a problem.
Yes, the step-by-step method of solving the problem is specified using a flowchart. This helps you to be clear about the input, procedure, and output. It also helps you to communicate the solution. So the concepts of a flowchart is the uses of flowchart is to specify the method of solving a problem, to plan the sequence of a computer program, and communicate ideas, solution, etc.
The guidelines of drawing a flowchart is: firstly, follow step-by-step thinking and logical reasoning of solving a problem. Secondly, identify the goal or the solution to be found. Thirdly, think of the sequence of steps for working out the solution to the problem. For example, identify start, input, process, output, and end. Next, use appropriate symbol to represent each step in the sequence. Use directional arrows to show the flow of the sequence of steps. And lastly, check that the flow of the solution is clearly communicated through the flowchart.
Now consider the following problem and draw the flowchart for its solution. Savani bought a toy for 225 ringgit and sold the same for 458 ringgit. Explain how we can find if Savani has made a profit or a loss.
In this problem, the goal is to find whether Savani makes a profit or loss.
We know the cost price and selling price. We can read them as input, so they are represented as parallelograms.
Next, we have to compare selling price and cost price to find which price is more. This will tell us whether Savani has made profit or loss. How do we show comparison in the flowchart?
Can you phrase this step as a question with the two possible answers?
We can ask a question: is selling price more than cost price? The answer to this question can be yes or no. If answer is yes, we have to calculate profit, and if answer is no, we have to calculate loss.
Right. In this step, you have two alternate actions that can be taken. The decision of which action has been taken is decided by the answer to the question. The answer can be yes or no. This decision-taking step is represented as follows in the flowchart.
If the answer is yes, it means that the selling price is more than the cost price and Savani has made profit. Profit is calculated as selling price minus cost price. If the answer is no, it means that the cost price is less than selling price and Savani has made loss. Loss is calculated as cost price minus selling price.
Good. You have used logical reasoning to solve this problem. Now draw the flowchart of how to find profit or loss in the flowchart. In a given example, so here's the start. The input is read. Cost price equals 225 ringgit and read selling price SP equals to 458 ringgit. So in the problem decision making, is SP greater than CP? If yes, equals the profit minus SP minus CP, and then print profit, and then stop. Print profit is the output. So in the second decision, is SP greater than CP? If no, loss equals the CP minus SP, and then the output is print loss, and then we stop. In the output, Savani made profit of 133 ringgit. As the processing, the profit 458 minus 225 equals to 133.
So these are the flowchart symbols and their purpose. The first geometry shape is ellipse. The purpose of it is start, end, stop, and exit, which means these are end. Secondly, parallelogram. The purpose is data, input, and output. Thirdly is rectangle, which means action, activity, and process. Next is diamond. The purpose is decision-making step, Specify the question in the diamond. The next logical step is based on the answer yes or no to the question. And lastly is arrows. Arrows are used to connect the steps in a flowchart to show the flow or sequence of the problem-solving process.
Sometimes we need to repeat a sequence. How do we represent this in a flowchart?
Let us consider the multiplication table flowchart that you all saw at the exhibition. See how repetition is represented in a flowchart? The flowchart of a multiplication table for a given number n. So here's the start. The input is read number n, and then here's count equals to 1. And then there's the input print n, output print n count. And then here's the decision is count equals to 10. If no, add once the current value of count until the process repeated, it becomes 10. So is count equals to 10? If yes, equals to stop. And then we stop. So there's the multiplication of 12 up to 10.
Excuse me.
The repetition sequence stops when comes to 10. So here a decision structure has been used to start and stop the repetition.
Try out another problem to see how you can use such an assignment.
Let us draw a flowchart to find the factorial of a number.
How do you find the factorial of a number?
Suppose the number is 10, then factorial of 10 is calculated as 10 equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good, draw the flowchart. So we find the factorial of n. Here's start, read n is as the input, and here's the process set m equals to 1, set f equals to 1. And then the process is new value of f, current value of f multiplied by n. And then here's the decision. Is n equals to n? If no, we add 1 to the current value of n until the current value of n multiplied by n is equal to n equals to n. If it's yes, we'll print loss, and the factorial of 10 is 3,628,800. And then here's the end. So good. For the examples that we have seen, can you summarize what are all the basic structures of representation?
In the addition of numbers example, we saw how to show a sequence of processing steps.
In the finding profit and loss example, we saw how alternate sequences can be specified using a decision box.
In the multiplication table and factorial examples, we saw how to show repetition of a sequence.
Flowcharts can be drawn for a problem-solving process using these three basic structures. As for first is sequence. Sequence of steps are represented by symbols that you follow each other top to the bottom or left to right. And next is selection. A condition of a question is specified in the decision box based on the evaluation of the condition. One of the logical steps is taken next. The next logical step can be a process decision or end of the flowchart. As for repeating or looping, either the processing repeats of the control leaves the structure. If it is yes, it will go straight down, and if it is no, it will go to the right.
Good. Now let us consider a game. Do you know the games of snakes and ladders?
Yes.
Okay, draw a flowchart to show how the game is played. So the snakes and ladders game flowchart, we start the first player throw the dice, move the coin, and if you land it on the snake head, if yes, slide down to the tail of the snake and give dice to the second player. When the second player throw the dice and move its coin and land it at the bottom of the ladder, if yes, move up to the ladder and give dice to the next player. And the third player throw the dice, move his coin, and he reach the last block of the game, no, and then he gives dice to the next player, which is the fourth player, and he throw the dice, move his coin, until if all of the above he didn't get, but he reached the last block of the game, if yes, he's the winner and the end. So the conclusion is flowcharts represents what we do in our daily lives, and different kinds of flowcharts are essential for different types of tasks, for different kinds of occupations. the things we do, how it also influence on what we study, what people work, and how we do things. Thank you very much, and see you again. And see you next time.
Thank you.
Okay, good rehearsal. We did it about 15 minutes. Very good.
Stop the recording.
Wait. It's recording. Adrian is recording.
I mean, like, we have done
Adrian,
already, right?
Adrian.
Yeah, yeah.
What?
Nothing.
Adrian, can you say again?
Adrian, Adrian, பைத்தியம்.
We have already done right. Just stop the recording.
Start recording. Okay. But do you want to do one more time? One last time?
Rehearsal?
No, this is for real.
Oh, for
Real.
real, okay, fine.
Okay. Stop the recording and record a new one.
Yeah.